All right. So number one, this is just, you need to memorize this if you don't know it. Eastward is the answer. So the Earth rotates toward the east. And that's why we really haven't gotten into time zones. Maybe we'll do a warm-up about time zones next class. When you fly west, I don't know if anybody's flown to Chicago or Washington State or California. Do you need to set your watch forward or back?
Back.
Back. So
3 hours back.
So the Earth rotates. The Earth rotates toward the east. The east is sort of like the future. So when you go east, you add hours. You need to set your watch ahead. When you go west, you take hours away. So it's eastward. And if you're looking down on the top of the Earth like this, just imagine you're up on the North Pole and the Earth is rotating eastward like that. What you'll see from the top is that it'll be going counterclockwise. You've got to know that. You can either figure that out by saying, all right, if I'm looking down like this and the near side's going to our right, it's got to be going that way, or you can just memorize it. On the diagram to the right, carefully shade only the dark part of the Earth. If the sun's on the right, the dark part's on the left. And I didn't ask you anywhere on this diagram to show which way the Earth is turning, but it's a lot easier if you put a little arrow on there showing that everything is going to be moving eastward. So that leads us to number 4 in the diagram. Which letter is experiencing a later time of day? So which one, A or B?
B.
So if I label the times on here, this time right here, this is midnight. This is 12 a.m. Right here, is this sunrise or sunset?
Sunrise.
You know it's sunrise because we're moving to the east, so you're going to go out of the darkness into the light right here. So this time right here would be 6 a.m. And right over here, when we're on the side closest to the sun, what would that be? That would be noon, 12 p.m. So 12, or A would be between 12 and 6, that's about 3 a.m. And B is about 9 a.m. So as you go toward the east, it gets later in the day. That's why when you fly eastward, you add hours to your watch. You set them forward. When you fly westward, you set your watch back. So later time of day is B. In the diagram, what's the approximate hour at A? 3 a.m. 3 a.m. is the time at letter A. And you can tell 3 a.m. is the time at letter A because the place opposite the sun is midnight. The place where you're entering the light is sunrise. And we're moving from left to right. So at A, it's between midnight and 6 a.m. Moving on to the next part. Number 6 tells you to carefully shade only the dark part of the Earth and the moons. Sunlight's coming from the left, which is a little bit different than the way I've given this to you before. The sun was on the top and maybe on the right. So I need to shade just the right side of everything. And it would help now, although the question doesn't ask me to do it, to show how they move. So if this is the North Pole of the Earth, how does this Earth rotate? Clockwise or counterclockwise? Counterclockwise. So the Earth's rotating like this. And which way is the moon going around the Earth? Counterclockwise, like that. And if you want to put the other moons in here, just so you can get a better picture, you could. So the other moon phases, there's one nearest the sun, opposite the sun, top, bottom. There'd be one in here. How many different phases are there altogether? 8. So I could do these other ones if I needed to, but I'm not really asked about them. But those will help in terms of thinking about how many weeks it takes these moons to go around. So what would an observer see if he or she were standing on the Earth looking at moon C? So if we were looking out at this moon, if you turn your paper and you just imagine what you would see from this, you would only see the near side. You would see this part. So what you're looking at would be what? Mostly light, and light on which side? On the left. So you're supposed to draw that. If you draw a circle and then you make it mostly light. With the light on the left, that means there's a little sliver of darkness on the right. So that's what it would look like. And the name of this is the light on the left or the right? The left, which means it's doing what? Waxing or waning? Waning. And what's the shape of it called? Gibbous. So this is a waning gibbous. The name of moon phase D, so if I imagine looking out at moon D from the Earth, what I'm going to see is, what would this be called? What do you see if you're looking from this side? You see the dark side, nothing but. So that'd be a new moon. Next one, how many weeks does it take to go from position C to D? So here's C, and there's D, and which way does it go? Does it go counterclockwise or clockwise? Counterclockwise. Now, with all the stuff I've drawn on here, I've already divided this into quadrants. How many weeks is a quadrant? One. So this is about a half a week, and then we've got a week. So the answer is 1.5. The next question, what approximate time of day does moon C rise? So to figure this one out, you keep your eye on moon C and then put your pencil or your finger on the Earth and just have it go around and around and around, and think about when you would first see moon C. So I can see moon C all on this side, and I can't see it all back here. I would first see it right there. So that's when moon C rises. Now I've got to figure out the time of day. So to do the time of day, to get some other reference points would be helpful. Right here, this is the edge of darkness. This is either sunlight or sunset. Which one is it?
Sunrise.
Is this going into darkness or coming out of darkness? Going into darkness. So this would be sunset, 6 p.m. And right here, middle of the dark, that's midnight. That's 12 a.m. This place right here, this would be 6 a.m. where you're going into the light. And then this is noon, 12 p.m. So back to the question of when does this moon rise? It rises when we're here, which is between this and that. So what time is it?
3 a.m.
3 is between 6 and 12?
Oh, no, I thought you were doing C.
I am doing moon C. Moon C becomes visible for the first time right there.
Oh,
Now, you'd see it the best at 3 a.m.,
9 p.m.
but it's 9 p.m. Number 12. So this is just way out of the blue. You can use that diagram on the other side to answer this if you want to. What time, or you could draw a whole new sheet for this. What time of day does the first quarter, a waxing quarter moon, rise? So I think the easiest way to answer this question would be to go back to this diagram and try to figure out where a waxing quarter would be. And there are a couple ways to do it. Waxing means doing what? Getting bigger or smaller? Bigger. So what's the smallest moon of all? Where does the whole thing start? With a new moon. This is a new moon. Now if you go around like this, all these moons, once you're starting from a new, these are all going to be getting bigger. And then there's a full moon, then these are all going to be getting smaller. Where do you think the quarter moons are? I mean, we can do a guess and check and figure it out.
You're at 16.
This is a quarter moon and this is a quarter moon. They're a quarter of the way through it. Now, which one do you think is what was the question? Waxing or waning? Waxing. Which do you think is the waxing quarter moon? The one at the bottom of the picture or the one at the top?
Bottom.
Well, so let's check and see if that's right. So the sun's on the left. I'm going to shade the right side of the moon. And now I'm going to turn my paper and pretend I'm looking out at it from the Earth. So here we go. Turning my paper. If I look out at this moon from the Earth, the side that I see, is that going to be a quarter moon? Is it half light, half dark? Yep. And it's half light on the right, so that's the waxing quarter. So I've got the moon. Now I just need to figure out when it rises. For that, I've got to have the Earth. So keep an eye on the moon. Tell me when I would first see that moon on the Earth. Can I see it from here? No. Tell me when I can first see it. Right there. So what time is it right here?
12.
If you label all the times, then you'd have it. This is noon. This is 12 what? AM or PM? 12 PM, noon. So the answer, you could either say noon or you could say 12 PM. All right. The name of an exceptionally high tide, what do you call these? Spring. And the low tides, they're called neap. So that's just a memorization thing. You've got to memorize what those are. Which moon phases are associated with these? So now you could either just memorize this. Some of you probably know. Spring tides, what would those be? New and full. And how about the neap tides? Yeah, just the quarter moons. So if you went back to this diagram, whenever the sun and the moon and the earth, whenever they make a line, meaning the new moon or the full moon, that gives you extra strong spring tides. And whenever the sun and the earth and the moon make a right angle, that's neap tides. So these quarter moons, they're going to be neap tides. So the neap, they're quarter moons. And the springtime tides are full and new. You're in a coastal town. About how often will you experience a low tide? So, actually, let me just redraw. I'll draw a little picture over here. This is the moon, and this is the earth. And the earth rotates around like this. So, where are the low tides on here? There's the moon. There's the earth. So there'd be a low tide here and a low tide here. So to go from here to there is going to be how many hours? 12. So the answer is every 12 hours. So to go all the way around is 24 hours. So from one low tide to the next low tide is 12 hours. So every 12 hours. And if you were going to explain why, you could use a diagram and explain that way, or you could say low tides are on opposite sides of the earth. So 1/2 rotation, or 12 hours, is required to go from one to the other. I'm not going to ask you this on the quiz. I've just decided it took so much writing I don't like it. So I won't ask you to explain why. Don't worry about that. You should know why, because that'll help you get the answer right. All right, number 15. The two types of eclipses. What's one kind?
Solar.
So I heard solar and I heard lunar. Let me fix my pencil. Oh, I think I'm out of lead. Not quite. Solar, lunar. So solar, when do you get a solar eclipse? New moon. And during a solar eclipse, so this is a solar eclipse right here. If you're standing there looking up in the sky, what do you see? What happens? This happened this summer. The moon covers up the sun.
Yeah.
And then a lunar eclipse, when does that happen? Full moon. That one happens when the moon is here. Does anything cover up the moon? The Earth's shadow falls on the moon. And there's the bonus. I'm not going to explain it. If you want to do that for homework and turn in a good, it says use words in a diagram to explain why these lengths of time differ. I need to be able to read it, and anybody in this class should be able to read your explanation and say, oh, I get it. So you've got to really understand it and then explain it well.